All right, so the first example here, solve the equation 2x squared minus x equals 2. All right, this method will work for equations that have nice, clean, rational answers and others. All right, so we hit the home button, brings us to the home screen, which is what you see in front of you. Go to equations. Let me get rid of this. So you hit OK or execute on add equation, type it in. All right, you could use one of the templates and modify it if you want. All right, but I'm going to do it from scratch. So you type in 2 and hit the X key, which is right here. Power of 2 minus X equals, so the equals is right above the pi button, so shift pi brings up the equals, and then type in 2. Hit OK or execute. Asks you if you want to solve the equation. We do, and it gives us a solution. All right. It also gives you the discriminant, right? The value under the radical, but I think that's kind of obvious because the value under the radical is whatever the value under the radical is, so it's pretty straightforward that way. All right. So x is going to be equal to 1. I'm going to write it as plus or minus rad 17 over 4. All right, so nice and easy. Again, the keystrokes were hit the home button, go to equations, type in the equation. All right, so then solve the equation. Really couldn't be simpler. All right, when you get into other types of functions like trig functions and things like that, you got to be careful about the domain. But that's just kind of the gist of it. So that was the first example. The second one, evaluate each. All right. So if you're evaluating it, you may want to use the table. You know, if you think about the TI method, you'd use a table of values, figure out f of negative 2. That's what is y when x is negative 2. Right. But you can do the same thing here. You go to Grapher, add an element, same deal, type it in. If you want to just choose the template that has the f of x in it, so you don't have to worry about bringing up the x, that's fine. This is a common log, so just log. In this calculator, there is no separate negative minus key, right? In the TI, you have a negative key and then you have the minus key. And if you ever got a syntax error, that was probably what you did one instead of the other. So I'm going to put in the minus symbol or negative symbol, 5x, lock it in. Add an element, 3 sine of x. All right, I didn't make a statement about domain here. You'll notice that when I go to functions now, it brings up g of x, which is good because I already used f of x. So numworks automatically makes that distinction and just goes to the next available letter, I guess, to keep it simple, down the line, identifier. All right, so 3 sine of x. Now, one thing you're going to want to be mindful of is something got a little wonky there. I never deleted the x. You got to be careful about whether you're supposed to be in degree mode or radian mode, right? If you're ever comparing a trig function to a non-trig function, most likely you should be in radian mode, right? Because radians are linear measures, so treated in terms of x and y. Those will give you linear relationships. Even if you're going around a curve, you can still measure it in terms of linear distances, right? So radians do the same thing. And so if you're comparing a trig function to something that is not trig, typically you're going to be in radian mode, all right? So I can plot the graph if I want, have a look at it. It's kind of a mess. Or I can just go to the table of values. So hit the up arrow. If I'm ever locked into a screen that I don't want to be in, for example here, you could hit the up arrow a bunch of times to get somewhere else, or you can hit the go back and it'll bring you right up to the column headings, or the tabs at the top, I should say. Go to table. I'm looking for f of negative 2. So it's not in my list here, so I can set the interval. I don't want it to go from 0 to 10. I want it to go, for example, from negative 10 to 10. Confirm. And now I have some more values to work off of. So f of -2 is equal to 1. G of 0 is equal to 0. All right. So again, and before I get onto the other ones, I'll just kind of recap here and go to Grapher. Penmanship. Grapher, type in equations. And then table. All right. So again, going back to the table, I can pull out f of 2 pretty easily. Well, easily in the sense that it's a non-real answer. So that's great. So this is going to give me no solution. So I don't have to worry about g of pi over 2. All right. But we'll get to that in a second. We don't have to worry about it for this one, but we may have to worry about it for the next one. And the reason it doesn't give us an answer is because if I plug in a 2 for x here, that makes the log that of a negative number. So log of a negative is non-real. Can't take log of 0, can't take log of a negative number. All right. Now, for the last one, it works inside out. It's a composite function. So I need to find g of pi over 2 first, then take that result and plug it into f. All right, my scale is not set up for that, but what I can do is set the interval, and let's say we're going to go from 0 to pi instead of 0 to 10, and go in increments of pi over 2 if you want, or pi over 4, pi over 12. It really doesn't make a difference as long as pi over 2 is one of the values. All right, since we're looking for pi over 2, I'll just use that as my step, confirm it. So now it's counting in terms of 0, well, counting in terms of pi over 2, so 0, pi over 2, and pi. You can tap on exact results, and sometimes that gives you something other than what you would like. So, maybe not. But if you look at the G column, you see that at pi over 2, it gives you a 3. All right? So this is really saying f of, because this whole thing here, this piece, is equal to 3, this is really saying f of 3. So now, it's an extra step, but I can go back to my set the interval and just replace it with, I can go 0 to 10 in 1 unit increments. All right, the step is the increments, the space between individual values. Hit OK, then go to 3. F of 3, non-real. So all of that for not much of a payoff, but it's something. All right. It's a technique that'll work it worked here. It worked to tell us that there was a non-real answer, right? But if there is a real answer, it'll work to give us that too. All right. We could also do it through the table. I'm sorry, that was the table, through the graph. So if you're on the right graph, see you have the different options. You can hit the up and down arrow to toggle back and forth between the graphs. Now, if it's a nice clean number, you might be able to scroll to it, but I'm going to go to calculate. And for the G function, you see the option find x given y, find intersection, find minimum, maximum, zeros, and so on. You do that, all right? You have options, you have, well, I'm not really going to get into derivatives here, but that's where you'd find that, all right? Or you could just type in this case for x, pi over 2, hit enter, and, hit OK. I'm used to the TI language. So if you hit OK, you see at the bottom of the screen there in gray, it says x equals the decimal approximation of pi over 2, and g of x, which is the y value given that x value, is equal to 3. So you get it that way. And then if you want, you can go back in to calculate, go to the f function, and now type in the 3, and it says undefined, all right? So once you type in the number, you can hit down or OK. I'm just in the habit of doing OK. All right. Now for this one, it's a home statistics app. hit OK. So in all these values go into value V1. Oops. They write the one as a like a ordinary font. It really should be a subscript, but it doesn't really have the wherewithal to do that. But I'll type my data in. So you go into that. I mean, the default is to put you in the first cell, so you just start typing 0, 0. You'll see for every value I type in, it provides a frequency of 1. Right? That's saying that I just typed in one number, now another number, now another number, and so on. But if you recognize that you have common values, you could change the frequency by saying, let me just wipe this out. Yeah, I have a 0, but I also have another 0 in there, so let me make that a frequency of 2. I only got 1.0, not 0.05, 0.5. I only have 1, 1. The data is in increasing order, so it's pretty easy to see. Only 1, 1.5, 1.75. But I have 3 2s. 3 2s. And almost failed the eye test here. 1 2.1 and 121. And I thought it was at first a pair of 2.1s. All right, so you just double check to make sure that your frequencies add up to the total number of values in a set. Now you could have just typed in each value individually, 0, 0, 1, 0.5, 1, so on. But if you have multiple repeated values, you may consider doing it this way. So 2, 3, 4, 5, 6, 9, 10, 11. 4, 5, 6, 7, 8, 9, 10, 11. Good. So then up to stats. And we're going to pull out the mean. Now you'll have two types of means here. You'll have the population mean or the sample mean. We don't have any indication that this is an entire population of data, so we'll assume it's a sample mean. So that's the X bar. Thing stops moving on me. X bar is equal to 3.0773. We typically go 3 significant digits, which means once the zeros stop. So you start at the decimal point. So it's not the same as sig figs. Start at the decimal point and you start taking note of digits. If the first value after the decimal point is a 0, ignore it. If the next one's a 0, ignore it. If the next one is not a 0, that's when you start the count. All right, so 3 values once the 0 stops. So for example, if I have 2.015398. All right, so ignore this 0. You start the count here, 1, 2, 3 decimal places, and then round that third one appropriately. So 2.0154. Another more probably absurd example, 0.000000012 95, something like that. All right, a whole string of zeros. Start the count here, and then round appropriately. All right, so 0.12345 zeros. The 5 is going to cause the 9 to go up, all right, so, which is going to cause the 2 to become a 3, so this would be 130. All right, now if I have something like one final example here, a little partition there, 5.1 0010009. All right, so in this case, starting at the decimal point, go to the right, ignore the first 2 zeros, 1, 2, 3. Even though these 2 values here are both zeros, they're still accounted for. All right, we don't disregard it just because it's 0. We disregard a string of zeros following the decimal point. All right, so that second 0 goes up to 1, so you get 5.00101. All right, just a brief aside on rounding because we're going to use that throughout the entire course. At the bottom, you see mode, and it tells you how often that modal value occurred. Right? Now in this case, we just want the mode, which is 2. But when it says mode frequency, it's saying that 2 occurred 3 times. If you have like 5 or 6 different modes in your data set, it'll report every single one of them. Right, the minimum, back to the top. Min is 0. First quartile, Q1, is also known as the lower quartile, 0.5. The median, abbreviated, shockingly, MED, is equal to 1.75. Upper quartile, 2, also known as Q3. The maximum, abbreviated max, surprise, surprise, 21. You know what, I didn't put the abbreviation for min. Or, I'm sorry, for minimum, which is min. The range, normally we'd have to figure that out. You subtract min from max, but they just tell us capital R is equal to 21. Mid-range, they don't tell us. There you go down the list, it's nowhere to be found. Mid-range is the min plus the max divided by 2. All right, so 0 plus 21 over 2 is 10.5. Interquartile range, that's something they do tell us. Oops, IQR. .5. Construct the box plot and determine if there are any outliers. All right, that is actually, with either calculator, is pretty easy to do. So what we do is we go to graph. Select the one that says box plot. All right, box plot. Now, there's 2 types of box plots that are embedded in this. So if I go to settings, you'll see an option to display outliers. If a question tells you just to create a box plot, we never want this activated. So I'm going to turn that off and then hit the go back arrow. And this would be my box plot. All right. Now what I want to do is I want to create a number line that incorporates the scale. 0. Now they went by 4s. It seems reasonable. Whatever scale they come up with for a box plot tends to be pretty okay. It's the histograms that can be a little wonkier. All right, so I'm going to go by 4s. So 4, 8, 12, 16, 20, and then 24 would be the larger than my largest value. All right. Now you see if I hit the right or left arrow, it brings me to the precise value at the bottom of the screen. You can see 0 for the first one, 0.5 for the second one. I just want to ballpark that. Here's 2, here's 1. I'm just cutting the distances in half. So half of that distance would be 0.5. So we're going to put it right here. 1.75, that's going to be between 1 and 2, closer to 2. Then a 2, and then all the way up to 21. So here's 22, half of that is 21, or half of that distance gives us the 21, I should say. Box around the middle 3, they may not be directly in the center. And then extend out to the extreme values. Got to move my point here a little bit, but that's going to be the box. Now, it didn't ask us to evaluate this box plot, but this one shows an extreme right skew, right? Tails off more to the right. Outliers. So that should be pretty obvious at this point. Settings, we went in there to display outliers. Well, we turned it off. Now we're going to turn it back on. Any loose point in my box plot would be considered an outlier, so outlier would be 21. Now we're not given any context for the data, so I can't say like 21 what, 21 hours, 21 miles. it's just 21 at this point. But when we get into the contextual situations, we're going to make sure that we address what that 21 represents, among other things. All right. So now the same idea with a full-blown frequency table. Right? This was a raw list, but I actually kind of treated it like a frequency table. So we're actually going to use the exact same process. So if you wanted to either skip ahead or, pause the video and try it on your own, and then, come back and see if you did it right, either way is fine. All right. Now this app that I'm using, it allows you, if you're using the desktop version of it, so if you're using it on your computer, it allows you to save your sessions. So if you use the app online but on a computer, you can save the work that you did previously. So if you did the last problem, let's say 2 weeks ago, and you wanted to reuse a lot of the same structure, you can call back your previous work. This calculator, like on a phone or on a tablet, it just keeps whatever you most recently did. So if you overwrite data, it's gone, replaced with the new data that you have, right? So when I get rid of this now, if I were doing it on a desktop, I would save my session so I can come back to it if I wanted to use this data again. But on this app, I unfortunately have to wipe it all out. And that goes the same for the handhelds. All right, so I'm gonna go right up onto the Volume V1, hit the clear button or the backspace, and it asks me if I really want to do that. And I say, yep, I do. Now, fortunately, I'm typing in a much smaller data set. Well, maybe not much smaller, just smaller. Or at least it feels that way. But in reality, despite the fewer keystrokes, like the less typing, I'm actually typing in more data because there are 10 ones, 3 twos, only 1 3, 8 fours, and 5 fives. All right, so same deal. Go to stats, grab all our stuff. All right. So the mean going on down. Again, we have no indication that this is a population. So X bar is equal to 2.815. The mode is a 1. It occurs 10 times, but it's still the mode. The minimum, a lot of oops. Min is equal to 1. Lower quartile, Q1, also 1. The median, 3. The upper quartile, Q3, is 4. And the maximum is 5. The range, 4. Interquartile range, 3. IQR. Oops, sorry, I skipped mid-range. That's the average of the minimum and the maximum, so 1 plus 5 over 2 is going to be equal to 3. Construct the box plot. All right, so I'll just kind of do that off on the side here. And again, constructing it means go to the graph, select box plot. All right, now I left, for the last problem that we did, I left my settings as display outliers. There are no loose points, which means there are no outliers. All right, when you select display outliers, what you're creating is a modified box plot. All right, so in that modified box plot, if there are outliers, they will be displayed. The fact that none are displayed here means that there are none. So 1, 2, 3, 4, 5. Both the minimum and Q1 are at the same location. Sorry, penmanship. So I'll plot a point there. There's 1 and 3. These are and 4 and 5. The numbers are actually really clean for this one, so not always going to be the case, but in this case it is, so it's great. Notice I have a tail on the right, but not on the left. That's because there's no need for a tail because the minimum and the lower quartile are at the exact same location. And again, there was no context here, so we would just leave it at that.